Assalamualaikum and hi. We are from Group 3. We present about use of analytical balances and volumetric glassware in pharmaceutical labs.
This is our group members. We have Nur Hidayah, Nail Aisha Umaira, Nur Hafiza and Nur Era.
Okay, first I will explain about the introduction. Analytical balance are highly sensitive instruments capable of measuring mass with a precision of up to 0.1 mg or better. It is crucial in weighing active pharmaceutical ingredients and reagents with strict adherence to pharmaceutical standards. A proper use of calibration of analytical balance are vital to avoid systematic errors and ensure reproducibility. I will explain a little bit of the material of analytical balance. The weighing pan is made from stainless steel or aluminium because it is non-reactive and easy to clean. Next, the body or frame. It is made from aluminium or die-cast metal with powder-coated or anodized finish. The reason is it is strong and stable to prevent vibration and deformation. Third is glass rough shield. It is made from tempered or anti-static glass because of its transparent for visibility. In addition, the internal components such as sensors and lock cells, it is made from electromagnetic force compensation system made from specialized alloys like copper, aluminium, and sometimes platinum. The reason is it has a high precision in measuring very small changes in mass. Lastly, the display and keypad. Made from LCD or LED screens with plastic or silicone keypad because of user interface for ease of use and feedback. Next is volumetric glassware. Volumetric glassware is including pipettes, burettes, and volumetric glass. It is specially designed for accurate measurement and transfer of liquids, calibrated to deliver or contain exact volumes, playing a key role in solution preparation, titrations, or solidation process. The material is for volumetric flasks, pipettes, burettes, and derivated cylinder. We use a borosilicate glass such as pyrex and urine. The property is it has a high thermal resistance, resistant to acids, alkalis, and solvents, transparent for easy reading, also durable and weight resistant. Other than that, for graduated cylinder, beakers, and disposable pipettes, use a plastic such as polypropylene or polymethylpentane. It is shatterproof and lightweight, chemically resistant, but it is not suitable for heating or very precise measurements. So in this case, we prefer to use a borosilicate glass.
Next, we have theory. Theory of analytical balance and volumetric glassware are fundamental instruments used in quantitative chemical analysis, particularly in pharmaceutical laboratories where precision and accuracy are critical. We have two theories. First, analytical balance theory. An analytical balance operates on the principle of comparing the gravitational force acting on a sample with a known internal electromagnetic force. These balances are highly sensitive and can measure mass to 4 or 5 decimal places. For example, 0.0001 gram. They are enclosed in a graph chart to prevent a current from affecting the measurement. In pharmaceutical analysis, precise mass determination is essential to ensure accurate formulation, dosage, and compliance with pharmacopoeial standards. Second, we have volumetric glassware theory. Volumetric glassware, such as pipette, burette, and volumetric glass, is designed and calibrated to contain or deliver very precise volumes of liquid. This instrument relies on the principle of volume measurement based on liquid displacement and are often marked with a calibration line to indicate exact volume capacity. The use of Class A volumetric glassware ensures the highest accuracy, which is essential in solution preparation and titration and dilution used in pharmaceutical testing. These two instruments support the fundamental concept of analytical chemistry, which includes accuracy, closeness to the true value, precision, repeatability of result, and reliability in measurement. This corrects with minimized experimental error and ensure valid and reproducible result, which is especially important in pharmaceutical application where patient safety and product efficacy depend on precise formulation and quality control. Moreover, use of analytical balance and volumetric glassware in pharmaceutical lab has its own objective. First, to identify the uses of analytical balance in pharmaceutical lab. Second, we need to understand the role of volumetric glassware in accurate solution preparation. Third, to recognize the importance of presentation in pharmaceutical analysis.
The analysis of the use of analytical balance and volumetric glassware in pharmaceutical labs. Analytical balance and volumetric glassware are very important tools in pharmaceutical lab. They help us get accurate and the exact measurements, which is important to make sure medicines are safe and work properly. Analytical balance measure very small amounts of powders, but they must be placed on a flat surface and protected from wind or vibrations. If not, they can give the wrong result. Volumetric glassware like flasks and pipettes are used to measure and mix exact volumes of liquids. Mistake can happen if the glass is dirty or if we don't read the liquid level correctly. Small errors in weighing or measuring can change the drug strength or how well it works. That's why we always use clean tools, follow proper steps like eye level reading, and calibrate our equipment regularly to avoid problems like fake tests or unsafe products.
Let's start with use of analytical balances. There are 4 methods of using analytical balances, which is number 1 is preparation. We need to ensure that the balance is on stable condition and vibration-free surface. We also need to calibrate the balance before use and close the door of the balance to prevent air currents or errors. Next is stirring, which is we need to place an empty weighing container such as weighing board on the balance and press the button to zero the display. Careful add the substance into the container using a spatula or dropper when weighing. Slowly add substance to avoid spillage or overdosing and record the mass when the reading is stabilized. Lastly is post-weighing. Gently remove the container and clean the balance area after use to avoid contamination. Next one is method in using volumetric glassware. There are 5 methods, which is first, we need to select the inappropriate volumetric glassware to accurate the measurement. Rinse the glassware with distilled water to prevent dilution or contamination. For filling, use a pipette filler or bore a funnel to fill the calibration mark and use dropper for volumetric flask to avoid overshooting. Other than that, make sure the eye level with the meniscus and use stopper to mix the solution and invert volumetric flask multiple times to ensure homogeneity.
Now, let's look at a simple example of how we prepare a solution in the lab using these tools. Here, we are preparing 100 ml of a 10 mg per milliliter paracetamol solution. First, we weigh 1 gram of paracetamol powder using the analytical balance. Then, we transfer the powder into a 100 ml volumetric flask using a funnel. We add a little distilled water and swirl to dissolve the powder. After that, we fill the flask up to the mark with more distilled water. Finally, we put the stopper on and turn the flask upside down a few times to mix everything evenly. This method shows how we use the analytical balance and volumetric flask together to prepare accurate and safe solution in pharmaceutical work.
Analytical balance and volumetric glassware are essential tools in pharmaceutical laboratories. They help ensure accuracy in weighing and measuring, which is critical for preparing precise solutions and maintaining the quality of pharmaceutical products. Their proper use supports effective drug formulation, reliable analysis, and compliance with industry standards. This is some of the reference that we have. Thank you for watching. Bye.